Howdy folks, so this video is for assignment 3 of exponential patterns. So I wanted to make a video on this because this requires something that we have not done in my class before. You need to go to a website called Desmos because we are going to be doing some modeling. So on the document I'm going to link on your assignment, you need to click on the link. And that'll open up a Desmos graphing calculator. So on the graphing calculator, here's where you're going to do your work. So you're going to plug in the exponential functions that are on the assignment into these lines here on the left. So I want to run through a little example with you. The example I chose was y equals 2 times 3 raised to the x power. So how I just wrote that, I basically just click on the line, then you type in y equals 2 parentheses 3 end parentheses, and to get the raised to the x power, you need to type the caret button in, and you do the caret button's like the upward arrow without the line under it. So that little triangle wing thing, that is the caret button, which you select by doing Shift 6. Okay, and then they type in X. You'll also need to, not for this example, but for your problems, you're going to have to plug in a fraction. So to do that, you basically just need to type /. So if I were to just make up something, so like I'll just make a linear equation. Y equals 1 divided by 2. So I clicked / after I typed 1 to get the denominator, and then I just typed 2. To get values after the 2, I need to hit the right arrow key, and then I can put whatever after that. Okay, so in your problem, you're going to have parentheses around the 1/2, and then you're going to have to raise that to an exponent. So then you would do the caret button and push the exponent you're using. All right, so I'm going to get rid of that line for now, though. So here is our example I'm going to run through. So we're doing y equals 2 times 3 raised to the x power. So once you have your equation in, you'll have a graph that looks something like this. You can move around on the graph on Desmos by just clicking in and dragging. And you can zoom in and out by using the scroll wheel. So scrolling towards you scrolls out, and scrolling in is scrolling forward. You can also use the touchpad. Alternatively, you can click the zoom in and zoom out buttons at the top right. So the top one is zoom in, the bottom one is zoom out. So you can click on these if you want, and they will zoom in and out of your graph. So in your problem, you're asked to find the coordinates for x equals -2, x equals -1, x equals 0, x equals 1, and x equals 2. You can determine these by using the trace feature on the graph you've created. So if I wanted to, for instance, find out what the y value is when x equals -2, I can focus in on -2 if I want. And on my line, I'll just click on the line, and I will just move my cursor over until I hit -2 for x. And it should kind of snap. It's a little challenging, but it will snap there eventually. So you'll see in my coordinate that'll pop up right above. It says -2, 0.222. So that is my x and y coordinate. So the f of x or y value is the 0.222. And if you get a decimal like this for your y value, I actually want you to convert it to a fraction for your assignment. So in that table, I don't want to see 0.22 reported. I want to see the fraction equivalent. Some of your graph will have decimal answers. 2 of the y values will be decimals on your graph, and 3 of them will be whole numbers. For the ones that are decimals, I'd prefer that you show me the fraction answer. So you can do that a couple different ways. If you want to use the trace feature on the graph, you can take the decimal and convert it to a fraction. Otherwise, you would need to use the equation. So when we use the equation, we need to select one of the x values. So if I choose x equals -2, I need to substitute that into the exponential function and then solve for y. So I take my -2 and I plug it in for x, this gives me 2 times 3 raised to the negative 2 power. When I evaluate that a little further, the negative exponent rule states that I take the 3 to the negative 2 and move it to the denominator and change the negative to a positive. That gives me a 2 over 3 raised to the positive 2 power. And 3 raised to the second power is 9, so my final answer is 2 over 9. Okay, so in my example, your table will look something like this when you are done. And you can find all these numbers on your graph by moving your cursor along the line until you hit each of the x values in your table. So the first two values, you'll see I had a negative 2 comma 0.222, which becomes 2 over 9. When x is negative 1, if I go to that point, it is 0.667, which is actually 0.6 repeating, and that converts to 2/3 as a fraction. And then the remaining three numbers will be whole numbers. So if I go to the y-intercept, I see that is 0, 2. So when x is 0, y is 2. As I move up the graph, you'll see it gets really high really fast. So the y value is going to start changing very rapidly. That's what exponential functions do. So when x is 1, the number, it jumps up to 6, so 3 times the value of the 0 exponent. And then if I want to find out what the y value is when x equals 2, I need to go all the way up. So I'm going to scroll out just so we can see how high this gets. So I need to scroll out and look for the x equals 2 line, and I go all the way up until it intersects the graph line, and that is at 218. So the y value when x is 2, it only increased by 1. It is 3 times as large at 18. You may even have to scroll out further for the problems in your assignment. The graphs will change based on the coefficient and the base of your exponent. Okay, so you also need to graph the parent function of your problem. So for this function that I've used as an example, the parent function is essentially whatever the equation is without the coefficient. For this kind of exponential function, that is just the base and the exponent set equal to y. So I basically just get rid of the 2. So I can go down to line 2 now. I will click here, and then I can either type that back in, or I could simply copy this and paste it here and then remove the 2. But just to remind you how to do it, if you don't want to copy paste, it's y equals, so then I would put my parentheses 3, and then to get the exponent, I do shift 6, which is the caret button, and you'll see I'm put in the exponent position now, and then I type in x. And you'll see on my graph, I have a new line. So this is the graph of the parent function, and as you can see, if I look at the y-axis, the graph for the parent function is half of the original function. The coefficient of 2 made a big difference in increasing the rate of the exponential function's growth. So at x equals 0, y is equal to 1 for the parent function, but it's 2 for the regular exponential function. So if we look at x equals 1, we see that the parent function is 1, 3. And as we know already, the original function is 1, 6. So the y value is twice as large, which makes sense. Okay, so next step, you need to take a picture of your graph. So to do this, computers have something called a snipping tool, and Chromebooks do as well, I believe. That, I think, is the easiest way to take a picture of your graph. So to use this, you can either type in snipping tool, and it'll look something like this, or if you're on Windows 10, there might be a newer version of it. But you will select this tool. It'll pop up. It'll say snipping tool is moving potentially. I use the new one, but for demonstration, I'll use the older one. I would click new, and then once this is my screen is grayed out, I will then select the boundary of my picture. So I will do up to -2, and I will go over like this and up there, and that should be enough of my graph so that I can figure out whether you did it or not. So then I will let go after I've clicked and dragged my boundaries, and that'll open it up in the snipping tool app. So once you're here, you should click on Ctrl+C. This will copy the picture, then go to your document, and for this I'll just temporarily delete this. To paste the picture, I would then press Ctrl+V, and that will paste the picture into your Word document. If your Chromebook does not have a snipping tool function, I believe you can use Ctrl+P. So hold Control and then click P, and then you can save the picture of your screen to your hard drive. From there, you can then drag it from wherever you saved it onto your Word document, and I should be able to see the graph that way. If you are a Mac user, I don't know exactly how you can do this. I think there are some alternative screen capture tools. I put a link to an article about that. Otherwise, you can use the print screen function. I assume that is still available to you. Okay, so now for the domain and range of your exponential function. This is the last thing you need to do for your assignment. The domain, as a reminder, is the set of all possible x values which will make the function work and will output real y values. And the range of a graph is the set of possible output values, or y values, which are shown on the y-axis. So for exponential functions, the domain of all exponential functions happens to be all real numbers. And you can tell this because to the left of my graph, it goes on forever. The lines go on forever. And to the right, it will continue to go up and slowly to the right forever. It will just continue to grow and grow and grow. And I can see that more clear if I zoom out on my graph. You can see it just goes up and right forever. So that is the domain. The range is either greater than 0 or less than 0, depending on if there's a negative or a positive coefficient in front of the base and exponent. Our example has a 2, a positive 2, that is multiplying the base raised to the x exponent. So the range for this example would be greater than 0. So for your assignment, I did an example, but you'll have something very similar, and that will go over here where these are. So you'll have your original function, which you'll type in line 1, and then your parent function, which you'll plug in line 2. You'll also have another assignment. If you want to use the same Desmos window, you can continue to work on this. Like if I had another function, just make up y equals 4 times 1/2 raised to the x. I now have a bunch of different lines, and that can be kind of annoying or confusing. So to get rid of your first problem, you need to click this button here. So this basically turns off and on those graphs. So you can turn off and on whatever you want, and then you can work on the next one. So then I would type in my parent function like so. Oops. And then I see that I have my new graph, which has a purple for the original function, and it is black for the parent function. So on your assignment, you have 2 problems. You'll need to graph those using the Desmos tool on your computer, and then you can take a picture of that graph, and you need to fill it. You also need to fill in the table using the graph or using the equation to solve for the y values. You'll see that on your assignment, I have put fraction equations already in your table. So I've already kind of hinted at what the answers would be for those 2. So in problem 1, you'll have fractions for your y values when x equals -2 and x equals -1. And in the second problem, you'll have them for when x equals 1 and x equals 2. Okay, so after you graph them, you just need to take a screenshot of them using the snipping tool or whatever method you can, and then paste it here. And then post your domain and range beneath your graph.